Hello everyone, let's try to learn the structures of AX5 molecule in this particular short video. I have already covered AX2, AX3 and AX4 molecules and its structures in detail in my previous video. You can check those. And yeah, just tell me how many electron pairs are there in this particular molecule? 5, right? 5 electron pairs are there. And here in this case all are bond pairs. So how can we draw the structure so that we can minimize the repulsions according to this VSEPR theory? How can we draw? We can keep two atoms over here and one more like this, है And one more thing, when you try to like studying these shapes and all, don't try to mug up this. See here, how can you remember the structure of shape of this thing? I'll tell you. See how it is looking. This is looking like a triangle, है See, it is a triangle, and when you connect these dots to all of this thing, it looks like a pyramid. And here one more thing is that if you connect these things, you can see like a pyramid. So it is trigonal bipyramidal, right? You don't need to mug up anything. So just see the structure, how it is looking, then you can just name it. Here, this is the standard case. It is electron geometry and molecular geometry both are trigonal bipyramidal only. And these are the deviations because it is having one lone pair in this case and there are two lone pairs in this particular case, and in this particular case there are three lone pairs, है ना? So but overall number of electron pairs are 5, right? So still the electron geometry is still the same, which is a trigonal bipyramidal, but a molecular shape will be different over here. So let me know the shapes of this molecular geometry of these molecules in the comment section. And one more thing, which is important concept over here is that here there are lone pairs, right? So where you will keep those lone pairs in this structure, huh? Right? So the generally these bonds are axial bonds and these bonds are equatorial bonds. Fine. I'll tell you the reason why we need to keep the lone pairs on equatorial position in my next video. I'll also explain you the examples for this, and example for this standard case is PCl5. So in my next video, I'll explain you these deviations, and I also explain you the reason behind why we'll keep the lone pairs on equatorial position.